All right, welcome everybody. This is our semi-annual virtual star party. We call it a Desert Skies Virtual Star Party, and we're coming to you from Tucson, Arizona. We've got some beautiful, clear skies out here tonight. We're waiting for it to get just a little bit darker. We'll have two telescopes tonight, one operated by Rick Paul and the other one operated by Jim O'Connor. And so we'll just kind of bounce back and forth between both of them. And I'll chat a little bit about the night sky and what you can see up in the night sky. If you happen to be outside, feel free to go out and have a look at some of the stuff that we were looking at with your eyes. Let me start. Let me just share my first screen. I'll just show you from Stellarium while we're waiting for the guys to get ready. So this is kind of what the sky looks like looking towards the southeast. So as you look out there, you can see fairly high in the sky a very familiar constellation called Orion, very recognizable with the three stars showing its belt. And then down below it is its sword. So here's its belt right here. And then this is the sword. And if you've got dark enough skies, you'll see probably Betelgeuse up here in his right shoulder and Rigel down here on his foot. But across from Betelgeuse, out here towards the front, is where his shield is going to be pointing out. And then back behind, coming out from Betelgeuse and up here, you'll see his club. And so that's a very familiar one. One of the first objects I think Rick's going to show is the Orion Nebula, and that one will be that's a really cool stellar nursery. So we'll let Rick talk a little bit about that when he's ready. But you can see some other kind of cool constellations around there. Just above and to the left of Orion, we've got Gemini, the twins. Their orientation is probably going to be more like about like that. They will be, let me go a little bit more. They're kind of on their side. So you'll see the bright stars of Castor and Pollux. And then coming out of those stars, the twins will kind of be going up to the right a little bit. And you'll be able to see the kind of the stick figures. And then so you get the top one and the bottom one. So those are kind of cool. And then almost straight up is a constellation called Auriga. And it's very prominent with a very bright star called Capella up here. It's kind of, as you're looking kind of towards the north, it's probably upside down with the figure on its head. And then, looking towards the north, you can start seeing some very familiar constellations. For instance, Ursa Major, the Big Bear. So the handle of the Big Dipper is kind of the tail of the bear, and then you've got the bucket of the Big Dipper, and that's the core of the bear. And it's kind of a little bit hard to see some of this other stuff up here because these are fairly faint stars, but that's pretty prominent. And then from the Big Dipper, we've got the bucket, and from there we have what we call the pointer stars, and so that's the bright two stars of the bucket, the upper part of the bucket, and these stars always point to the North Star, and here's the North Star right here, and that is part of Ursa Minor, or the Little Bear, and it's in the tail of the Little Bear. A lot of people can only see the North Star and maybe these two end bucket stars. But if you've got some really good dark skies, then you can also, if you can see the rest of the bucket and the two stars here in the handle, then you've got some pretty good dark skies. They're all slightly different magnitude. So that'll give you a good indication of what you've got going on in your night sky. And then if we look towards the south, from here, you can see just below Orion is Canis Major, the big dog, and the brightest star in the night sky is a star called Sirius right here. So as you come off the belt of Orion, if you just follow the belt stars going down towards the horizon, you'll see Sirius right here. Sirius is sometimes called the dog star because it's in the big dog. And this one, if you can see some fairly You can see most of this outline, and it actually kind of looks like a dog, a little dachshund or something like that, coming off the shoulder from Sirius, and you'd see kind of the body coming down, and then the feet pointing down here, and the feet pointing down here, and then a little tail kind of pointing up down here. So that's one that somewhat looks like what it's supposed to. Going the other direction from Orion's belt, going up a little bit higher and to the west, you'll see Taurus the bull, and it's usually most recognizable by the V shape right in here for his head. This is a bright star called Aldebaran, and it's pretty prominent. It has a pretty good reddish or orange reddish hue to it, but you can usually clearly see the V of the bull. Let's see, and then if we go further to the west, and it's getting close to setting right now, is the constellation of Andromeda and Cassiopeia. Cassiopeia is the queen, and so as you're looking due west, you'll see the W off to the north, and the chair is kind of upside down right now. This is where the chair would be. Her feet are pointing up, down this way, and then her body here, and she's looking over at her daughter, Princess Andromeda. And this is Andromeda, and a lot of times we'll show the Andromeda galaxy, which is kind of a cool one, but it's getting pretty low right now, so we probably won't be able to see that tonight. And then in between Andromeda and over towards the east, you'll see a bright Jupiter. That's the brightest thing up in the night sky right now, so that's out and very prominent. Don't have much for planets in the night sky right now. Most of them are either transitioning behind the sun. Some will be coming back into the night sky. I think Mercury's going to pop back in March. Mars right now is up in the morning. Venus, I believe, is still up in the morning. Saturn is just transitioning to the morning, so it's starting to move up. So right now we primarily have Jupiter. We've got Uranus, and I think Neptune's out here someplace floating around. But other than that, that's about it for the planets. And then when we're back to the north, we're looking back towards Ursa Minor and Ursa Major. So, Rick, are you about ready for your first one? Are you still
No, I need another few minutes here. I'm
okay?
getting there.
All right. How about you, Jim? You still working on your first one?
I'm ready,
All right,
but
then.
I'm going to use the second one on the list. First one, for some reason, my list keeps saying it's out of limits, so
Okay, I'm
I
going to
can
stop
come
the
back to
share,
it.
and you can go ahead and share your screen, and we'll start with you while Rick gets ready.
Let me figure out. It's been a while. Got to make this work. Got anything yet?
Yep, I see it.
Oh, goody. When Jim was giving his rundown on the sky, he was talking about how what people imagine a constellation to be isn't exactly what it looks like to our eyes. But in this case, this cluster has a name. First of all, I'll tell you what an open cluster of stars like that is. That's a group of stars that were all formed about the same time, cosmologically speaking, probably within a few million years of each other, out of the same gas cloud. And when they're done forming, both the energy of them starting to light up like a star and using up the gas to be a star makes the rest of the gas go away after a while. Here we have an open cluster whose formal name is New General Catalog 2169. Kind of dull, but astronomers starting about 200 years ago started calling it the 37 cluster. I like to show that one just because it looks like its name. You might have to tilt your head a little bit, but on the left side should be the number 3, or a group of stars that look like the number 3, and something that looks like the number 7 next to it. So that little object is the 37 cluster. And a little more of the the information about them is that that was found in 1784. It's about 3,600 light years away from us. It's fairly far distance. That's almost 3 times as far as the Orion Nebula will be. So that's a ways out there, 3,600 light years from Earth. And it only has about 30 stars. The stars you see that make up the 37, those stars totally are only 7 light years across. Now, a light year is about 6 trillion miles, if you want a number that makes a little more sense, but still, it's hard to wrap your head around 6 trillion miles. So this object here would be about 47 trillion miles from us, or not 47, 3,600 light years times 6 trillion, 6 with 9 zeros after it. So that's a long ways out there. And they're moderately bright. They're moderately well behaved. You got no crazy things going on. You don't have anything really old and giant that's going to blow up on us. It's just sort of sitting out there for us to look at it. And that is New General Catalog 2169, the 37 cluster.
All right, thanks, Jim. I'm just going to show you guys where it is in the night sky. So I'm going to stop your share, Jim.
Okay.
And so this is where Jim was looking, is up in the right arm near his wrist of Orion. That's where the 37 cluster is, or NGC 2169. And so that's going to be in the vicinity of where Rick will be going next, which will be down here in his sword. So as you're looking at Orion, again, we have his belt, and then if you've got some pretty decent skies down below his belt, you'll see what we call the sword. Now in the picture here, you can see the sword is a little bit off, a little bit is kind of down here in the sheath, but it looks like it's hanging down here. And you've got 3 stars or 3 objects in a row when you're looking at that. And most people can see all 3 of them. If you look very carefully at the center one, it's going to look a little bit fuzzier than the other 2, and that's because it is the Orion Nebula, or the stellar nursery, and all the stuff that it makes up. So Rick, you just let me know when you're ready to start showing that, and I think Jim's moving on to his next one.
Sorry, I'm still just having a couple bit of problems here. I'll be ready in a minute.
No problem. I'll keep talking here. So again, you can see as we're looking at Orion, he's we call this the shield, but he's actually holding one of the hunting dogs, I think that is. And let's see, let me just kind of go out a little bit. Yeah, it's kind of cool, if you go outside and look, the sky kind of changes focus, probably quarterly. I tell people if we do a lot of star parties, typically we want to try to do just the star parties, do them quarterly, because then otherwise we're spending a lot of time looking at the same part of the sky. So when we do our virtual ones, in the past we have done quarterly, but I think right now we're planning on doing primarily semi-annual. So we'll have a completely different sky when we look at the next one, which will be October 25th of this year is what we're planning for that one. And I will be, once we're done with this one tonight, if you want to let people know if they want to watch it later, probably over the next couple of days, I'll put it on our YouTube channel as well. And we have all of our past virtual star parties on our YouTube channel. If you go to YouTube and just search Tucson Astronomy or Tucson Amateur Astronomy Association, you'll find our channel, and under the virtual star party playlist is where we have our past virtual star parties there. And we have some other kinds of videos and that kind of stuff on there. So it's kind of fun. I'll put in a plug while we're waiting for Rick. I'll put in a plug for our Grand Canyon Star Party. If you're out west and or have a propensity to want to come to the Grand Canyon, every June we co-host the Grand Canyon Star Party with the National Park Service. This year, it's June 1st through the 8th. It changes in June based on when the new moon is. We try to do it around the new moon. And we set up about 60 telescopes a night for 8 nights. And it's just free and open to everybody that's in the park. And so that's kind of cool. We'll have all kinds of different things. We see probably, I don't know, 1,500 to 1,700 people a night coming through and looking through the telescopes. The skies are incredibly dark up there, and you're up at 7,000 feet, which means that you're just that much closer to the sky. You know, you're above a lot of the atmosphere, which really makes it everything just kind of pops out a little bit better from that perspective, because you're looking through a little bit less atmosphere.
Okay, Jim, I think it was worth the wait for everybody.
All right, you got it. You can go ahead and share anytime. I'll stop.
You got that up?
Yep, I see it.
Okay, so this is the Great Orion Nebula. It is located in the constellation Orion, which I hope everyone's familiar with. It's one of the most common visible constellations in the winter sky that most people recognize. This nebula is actually visible not only easily through a pair of binoculars, but you can actually see it with your naked eye. If you look up at Orion's belt and then look below his belt, you will see the three, I'll put in quotes, stars that form the sheath of his sword. Except if you'll notice, your eyes can't quite focus on those stars in his sheath. That's because they're not stars. That is the nebula forming that sheath. So if you aim a pair of binoculars up there at that part of Orion, you'll very easily be able to see this nebula. Now you won't see it in color like this. Your eyes aren't that as sensitive as the camera is. You'll see something that looks kind of gray, greenish to your tint. But the Orion Nebula is actually located fairly close to us. It's a nearby neighbor. It's only 1.4 thousand light years away, which for those of you who don't know what a light year is the distance that light travels in 1 year, which is a very vast distance. We use light years rather than miles because miles are not useful when you're talking about galactic distances. But 1,400 light years is relatively close to us. This is a very one of the most studied objects in our sky, even by professional astronomers today, because it is an active star forming region. In that bright center core there, reason that's so bright is there's new stars in there being formed, and they're putting off a lot of the light that's in there. So this object is also known as M42, which is for Messier 42. Charles Messier was an astronomer back in the 1700s, and he was looking for comets, and he was making a list of everything that wasn't a comet. Well, he got more famous for the things that weren't comets than any comets he discovered, because his list of objects are now considered, the most famous objects in the sky to see. But he did observe this in 1769, and was one of the first to note that he was able to see the nebulosity and three of the central stars, which again, with any pair of binoculars, you can see the nebula. So this is an easy nebula to see. It's I'm going to give you the size. I was looking that up. It's about yeah, it's estimated at about its widest part, about 24 light years across, which I'm going to be showing you some bigger objects than that tonight. But so that's the Orion Nebula. Jim,
Yeah.
you got anything to add to what I said?
No, that looks really good. You know, that really bright area is where the baby stars are. I kind of say that a little in jest because they're just a few million years old, but those are the youngsters. And so that's you know, that's this, like Rick said, this is kind of a stellar nursery. This is where new stars are being born. It is uh, gorgeous, even just visually in a telescope, because you can you know, that you, like Rick was saying, you won't necessarily see the colors, but you can see the cloud very clearly, and a lot of detail and structure to the cloud, which is pretty cool. And and so, you know, as more and more stars are born in this nebula or gas cloud, it will then start, you know, using up the gas. And then once it does finally use up all of the gas, then these stars would for a short period of time travel around the Milky Way galaxy in an open cluster. So our sun was born in a similar kind of cloud like this. All right, I'm just going to show them where it is in the night sky in Orion. If you want to go ahead and start going to your next one, Rick.
Yep.
And I've got one too.
Okay, so this is where we're looking. Again, we talked a little bit about Orion and the belt, and so as Rick was saying, this is the sword, and the middle one is the object, and you can kind of see right down here. If I were to keep zooming in, it'd show the picture of it, but that's the nebula. All right, Jim, over to you.
Okay, let me try to share a screen here. And I hope this one actually does show up nicely. It is kind of dim to send over the great Ethernet, but I'm hoping it comes up. This one, um, this item has a name of, and it's in the center of the screen and a little bit below the center. And the name of that thing is the Intergalactic Wanderer. And the reason is, while it looks like a fuzzy, don't care about what it does for us, it's actually a globular cluster in the constellation Link. A globular cluster is sort of a retirement home for older stars. Stars in a globular cluster tend to be, over 10.5 billion years, and it may be as old as 12.5 billion years. It was discovered a long time ago, about the same time as the 37 cluster, but it took us a while to figure out what it was. And some of the interesting things about it, we've been talking about light years. When I said it was 6 trillion miles, this cluster here is 300,000 light years from the solar system, and at the same distance from the center of the Milky Way galaxy. Yet it's still part of the Milky Way galaxy. The nickname, the Intergalactic Wanderer, was bestowed on it when it was erroneously thought that it was not to be in orbit around the Milky Way. Its orbit takes it further away from the center of the Milky Way than the Magellanic Clouds. Those are galaxies that are visible in the southern hemisphere of the Earth. It takes up to 3 billion years for that object to make a trip around the Milky Way. Since our solar system is about 4.5 billion years old, this is only its second orbit since our solar system was formed. One of the brightest and most massive globular clusters, although it looks kind of shady if you can see it, it looks kind of dim there. It's one of the brightest and most massive globular clusters of our galaxy. It's got a magnitude of, if you were close to it, its absolute magnitude is -9. That is incredibly bright. And it's got 900,000 solar masses worth of mass. That means it's as though it had 900,000 of our suns in there. If you looked at that object from the Andromeda galaxy, you look towards the Milky Way galaxy, that would be the brightest object in the Milky Way, even brighter than the core of the Milky Way galaxy. So that's a pretty spectacular kind of thing to sit there. It was thought to be not kind of interesting, but I I kind of liked it just because it was so far away and so unusual.
Yeah, and it's a little difficult if you want to kind of move your cursor over it, Jim, just so that
Yeah,
people
I'm right there.
yeah, it's that grouping of stars right there.
900,000 suns worth.
Yeah, so it's yeah, that's a very, very distant object to be able to view some of the older stars in our Milky Way galaxy. All right, anything else to add in, Jim?
Um, just that it wasn't known what these globular clusters were. There's a difference between an open cluster and a globular cluster. The open clusters young, they can be normally running around. Most of them will be about uh, close to 1 million years, maybe a little bit more old. Although there are three globular clusters we know that are 1 billion years old, and the reason they're I mean open clusters. The reason an open cluster can get to be such an age and not be dissipated across the solar system is that there's so many stars in that open cluster that their gravity holds them together. Normally, an open cluster, when it forms, like that 37 cluster, in a few tens of millions of years, those stars will drift away from each other due to the rotation of the galaxy. But a globular cluster has so many objects in a small space that its weight holds it together. And it was always a mystery where these came from. So about 15 years or so ago, maybe right now, close to 20 years ago, about 20 years ago, research was going on at Kitt Peak here in Arizona and at a few other at the time, large telescopes to figure out what those were. And so cameras that could see in the infrared were becoming common to use because they found a way to chill them, to get them cold. For example, the camera I'm using right now, that object you're looking at, I've got my camera cooled down to 20 degrees below 0 centigrade to be able to pick that thing up. Well, when you have it in a big professional telescope, you can go down a bit colder and grab a little more light. Well, what they did was they were looking at those things. We have 158 of these kinds of objects circling our galaxy, all of them a lot closer. And they started trying to look deeper into them and figure out what they were. The guesses were one, they're so old because they were open clusters that were close to each other and their gravity kind of been holding them together. And then the other thought was, well, maybe it was part of an older galaxy that the Milky Way is only 7 billion years old in the core, and these clusters of stars are over 10 to 12 billion years old. Maybe they were part of another galaxy. And the third was just two clusters passing by each other just happened to merge. So the research showed that all three answers were correct. Around our galaxy, some of the biggest ones we know of, Omega, there's one called Omega Centaurus, and there's another one in the Hercules galaxy called the Hercules cluster. They have intermediate mass black holes at the center. What that means is if they were a star, they'd have a few solar masses, a black hole when they went supernova. If they were the core of a galaxy, normally they would have millions of solar masses in their shape. For example, the black hole in the center of our galaxy is about 4.5 million stars. Well, an intermediate mass was never discovered. Black hole hadn't been discovered yet, even though theoretically it should exist. And what was discovered was that these globular clusters many of them, but not all of them, had intermediate mass black holes, somewhere around anywhere from 10,000 to 100,000 solar masses in them. And that meant that was the fingerprint or the tracing or the indication that it was the core of an old galaxy. So what that meant was when those smaller galaxies were first formed right after the universe really became able to form stars, um, they they were in a small galaxy, and giant galaxies later formed out of the clouds that were around them and pulled in all the gas out of these small galaxies. So what it looks like is These globular clusters are the cores of old galaxies.
All right. Well, thanks, Jim. That was a good description of what globs are all about and the number we have here. Rick, you ready?
Unfortunately, no.
Okay.
Things are just taking longer tonight. I'm sorry.
That's all right. Let me show everybody real quickly where Jim's object was looking at in the night sky. So he said we were looking in the constellation of Lynx.
Right
So if you're
there.
looking up off kind of to the east and high, again, here's Gemini, the twins, Castor and Pollux. They're kind of on their side. It probably looks more like about like that in the night sky. And then off to the north, you'll see, well, you probably won't see the constellation of Lynx because it's got a lot of faint stars and it would be very tough to make that out. But right off his belly is where Jim was looking at. That is the intergalactic wanderer. I'm going to bring up a picture of Rick's object, or as that.
Actually, my next object is let's see, it's NGC 2174.
All right, I'm going to show him a picture of your scope first, if you want to.
Okay, yeah, go ahead. I'll be ready in about 60 seconds.
Okay. So this is the setup that Rick is using. He's got a Stellarvue refractor. The camera is the red object back here at the back, and here, and it's on a Los Mondi mount. So that is the setup with all the wires and everything that he's using tonight.
Yeah, and there's a little blue box on top there. That is my power and communications hub. All the USB goes into that, and all the power comes out of it. So I got shorter cables that all go to one place. So it makes it kind of nice. Let's see here. I'm getting close, Jim. I got
Okay.
see. Oh, 15 more seconds and I'll have an image.
All right. Stop the share here, and you can just start sharing when you're ready.
Yeah, just need a minute. Downloading it.
A lot of times, most of the time, we do this with 3 telescopes, which actually is kind of the sweet spot because as we're showing one object, the other 2 telescopes can start finding their next one, and then we just kind of go cycle around, and that works pretty good. But our third scope tonight, we've got quite a few school events going on and local star parties going on, and he needed to go and do one of those tonight, so we weren't able to have all 3 scopes here, but that's all right. We may not go the full 2 hours. We'll just keep going, and you guys can come and go as necessary. And again, these you can watch the recording later on if you want to, either on Facebook or on our YouTube channel.
Okay, Jim, I'm gonna go ahead and share. I've got it here, sort of.
Okay.
It's better than nothing. Here.
Yeah, it's starting to show up.
Yeah, this is a little bit fainter than um than Orion. This one it has a number which is New General Catalog 2174. But it's colloquially called the monkey head, and I guess if you look at it from a certain angle, it kind of looks like a monkey head. This is also located in the Orion Nebula. It is up in the same order of magnitude distance away as the Orion Nebula was. It's about 1,370 light years away, so it's about the same kind of distance away. size is a little bit smaller. It's also not as bright. Although it's about the same distance to us that the Orion was, it doesn't have all that activity going on inside of it that's lighting it up like the Orion Nebula is. This is again a cloud of largely hydrogen gas. Is mostly what these nebulas are. When you see the red tinge to them, that's what you're seeing is hydrogen. They also have other elements in them, commonly oxygen and sulfur also. This one's coming black and white because I only have one image coming in right now.
It's not stacking it like it's supposed to.
Yeah, I think the problem is I've only got yeah, no, that's all we're gonna get on this one.
Yeah, well, that's all right. It looks pretty cool. I mean, this
Yeah.
would probably look, if, like when I was talking earlier about looking at the Orion Nebula through visually, it kind of shows shades of gray, and that's kind of what you would see here. Now, this is probably faint enough that you may not even be able to see it visually.
Yeah. Oh, no, this one you could not see visually. I don't think that you'd have to have a very large telescope to see any nebulosity to this one.
Yeah.
This one takes a camera.
So that's the beauty of having, and a lot of our amateur astronomers now use cameras to look at the objects in the night sky, because they can get a lot more detail and can see a lot more structure than you can visually. So we have kind of a good combination of amateurs that want to look at, and use the cameras, and the cameras and the telescopes have gotten so incredibly good that, they are certainly rivaling what the professionals did, as just 5 or 6 years ago. We're able to do in the amateur community as well, and it's not that expensive. You do have to have a little wherewithal with the technology, because as you can see from Rick's picture, it can get a little bit daunting at times to get everything connected up, but it does work very well, and so
Oh, and what we're able to do today in our backyards, professional astronomers 30 years ago would have drooled over.
right, yeah. So unless you have anything else, I'm going to show them where in the night sky.
Yeah.
Okay, so I'm going to take the screen and show you Stellarium again. So again, we're still in Orion. And up here in his right arm up here, you can see here's the intergalactic wanderer that Jim was showing in the 37 cluster. And way up here by his club, this is the Monkey Head Nebula. That's it right up there. And I don't know if it shows a picture. So if you zoom in, this is a picture probably taken from Hubble or something like that.
Yeah.
Good ones. But, Rick's, if he'd have been able to stack it real well, his would have come in with some pretty cool colors on it. But as you can see, there's just a ton of stuff to be able to look at up here in the night sky.
In 30 seconds, I might have color.
Okay.
give me 30 more seconds.
All right. But yeah, this is a very cool part of the night sky. You can see a lot of nice things up here. We've got nebulas, double clusters. About half the stars in our night sky are actually multiple star systems. Our sun is kind of unique in that it's, as far as we know, it doesn't have a pair. We haven't detected everything in the far out solar system, but at one point early on, when it was first born out of the nebula, we probably had a sibling that was joined, but something could have happened where maybe another star went supernova, or got too close and jostled them enough that they separated. But any more professional astronomers, and Rick, whenever you're ready to share your screen, just go ahead and start sharing. You can share over top of this. Professional astronomers can now, when they're looking at stuff like this, they can just do some incredible things with it. And there's just a lot to be able to look at out here. We have our association or club has an astronomy complex about 100 miles southeast of Tucson over towards New Mexico a little bit, towards the Chiricahua Mountains. And so when we want to get out of the light pollution of Tucson, which is still isn't too bad for a city of 1 million, but it's getting worse. Then we'll go out there, and we've got where people can bring their own telescopes, and we have a lot of imagers that are setting up and showing stuff and things like that, and looking at they're doing different imaging and stuff like that. And we've got places where they can stay out there. So it makes it really nice to be able to go out and do some serious imaging and get away from the dark, the bright lights. Are you ready, Rick?
I got a second image, but it's not stacking it for me. That's weird.
Okay.
Oh, well,
We
let's
can
go
go
ahead
on.
and go to Jim.
Jim, I'm going to share the slide again with your setup. If you want to chat briefly about
Yep.
that, and let's see, let me get it going here. Great. So this is what Jim is using. Go ahead.
Okay, there's what I've got set up. That's it. I took this picture about 4 hours ago, so that's exactly what I'm using right now. What you see halfway across the screen there is a big TV monitor. I don't need for tonight, because that would be if I had doing it in front of an audience. But I always try to set up exactly the same way every time. So right now I'm just sitting at that laptop and telling the telescope where to spin around the sky. It's a Meade LX5 10-inch, which means it's a Schmidt Cassegrain, which is, well, that technology was developed around the 1780s. And so, well, we've done a lot better with them. If you take a look at the front end of that telescope, it looks just like a 35 millimeter digital single lens reflex camera, and or even a film single lens reflex, because it is. That's exactly the technology that your nice camera uses, because that black dot on the front of it is another mirror. That black dot in the middle is a mirror that's sending the signal back to where the eyepiece would be, where my camera is right now. I have in that picture, if you look at, there's a tiny camera on the top. That tiny camera on the top is actually what guided it, was how I got its alignment. It's modern technology coupled with that Celestron AVX mount. It's actually a Celestron camera. Together, they let me align that in 3 minutes. All I have to do is touch the button on the controller. I don't have to look through anything. It spins around the sky, stops at 4 spots, finds 100 stars at each of those 4 spots, and gets a really tight understanding of its own alignment. And if you're polar alignment, that means aligning the telescope so that its axis is pointing towards the North Pole, or Polaris, near Polaris. If you do that, then all it takes is that 3 minutes of alignment, and you're ready to find whatever you need. So it's a pretty nifty thing. Finally, the camera I've got on the back end, it's a Meade DS10C Tech. What that means, DS is Sky Raider or Deep Sky. That's a line of cameras from the Mellencamp company in Canada. The 10 means it's got 10 megapixels on its big imaging frame. It's the thing that's grabbing this light. C means I do it in color, and the TEC, the TEC, means I have a thermoelectric cooling in it, which means it takes electricity and it's able to make it cold. And that's when I earlier said I'm at minus 20 degrees centigrade right now, to try to keep the image from getting extraneous hot pixels on it, because that's a lot of energy going through that camera, and those pixels really do like to show off, whether it's necessary or not. So anyway, that's my little setup, a Meade 10-inch LX5 on a Celestron AVX mount, and it's got a StarSense camera to align it, and a Meade DS10C Tech to bring you the pictures. And what I'm doing is I'm grab the pictures, come out of the camera, and goes right into the laptop, because there's only one wire of all those wires you see, there's only one wire driving the camera and me sending you the signal. And that's a wire coming out of the camera into my laptop on a USB line. And that's what powers the camera as well.
All right, very good. Are you ready to show your next object?
Yep.
Okay, I'll
Let me
stop the
try to.
share. You can go ahead and start. And while you're getting yours going, I want to just answer a question that was on Facebook.
Okay.
So, let's see, who was it? Carrie, I think it was, asked. Yeah, Carrie asked, could Jupiter have become a companion star to the sun? And I kind of answered a little bit on Facebook, but Jupiter is way too small to be a star, but it is made up of the same kinds of gases that the sun is made of. So if you envision in our solar system, of all the matter in our solar system, all, you know, the sun, the star, or all the sun, the planets, the asteroids, comets, everything in our solar system, the sun itself makes up 99.8% of the matter. Of the remaining 0.2%, Jupiter makes up 0.1, and everything else in our solar system, the Earth, Saturn, all the other planets, all the asteroids and comets make up the remaining 0.1. So although Jupiter is big, it would have had to have been much, much larger to be able to ignite into nuclear fusion and become a star. So, but it was able to get quite a bit of the gas and get pretty big. If you were to envision the ball of Jupiter, the round ball, you can put 1,300 Earths inside that ball when you look at it in the telescope. So it's big, but it's small in comparison to the sun. All right, Jim, over to you.
The thing I've got there on the screen is one of the closer of the galaxies that are out there. We know Andromeda is closer to us, but this one is only 12 million light years away. And it's called the Cigar Galaxy. It's Messier object number 82. It used to have a name it shared with Messier 81 that's just off the screen. The two galaxies are very close, but to separate the understanding of which galaxy someone was talking about, it was originally called Bode's Nebula, and the two galaxies together were called Bode's Nebulae, but now Bode's is strictly stuck onto M81, and this one is kind of mundane, called the Cigar Galaxy. That's a starburst galaxy. A starburst galaxy is one that's going through star formations at a hyper pace, at a very strong pace. You can probably see lumps all over that galaxy when you look at it, little white blobs. There are over 200 of those massive clusters of over 200,000 stars each, all of which have been formed within the last about million years. So it's cranking out stars prodigiously. And as a result, let me back up a little bit and say, we kind of wonder why is it doing that? And it turns out, if you look halfway along the line of that galaxy, you'd see a dark area. Well, that's a dust cloud in the middle of that galaxy because of all that action going on. And it looks like all those stars are being created because some other galaxy merged with it and provided its own black hole there. So there are actually two supermassive black holes in that galaxy. And it's causing, when a black hole comes in there and starts messing around with all the all the gravity it has, it causes the free gases in the galaxy to start clumping together and forming stars, just like we're seeing it just crank stars out right now. So it looked like it might emerge with another galaxy, but other ways of studying it with a lot better cameras than I'm using here has determined that there is actually a spiral arm working on that. So it was a spiral arm galaxy that was deformed somewhat by another galaxy coming in and merging with it. And now that result is creating a tremendous number of stars in that thing. And so that's that makes that thing large and bright. But where it looks like haze, like I haven't focused it very well at the sides and a little bit over the top, that's just stars. There are almost 1 billion stars in that thing. Now I talked about 2 200 galaxies of 200,000 stars each, you can tell you got an awful lot of stars going on. There are almost a billion stars in that one, really. And the reality of their light is you can see that haze around there. That's millions and millions of stars going around. But there's those balls of hot stars near the center are just newly formed, so they'll be a lot brighter. And that's why they're clumping in their own clusters of stars they're just created.
Oh, very nice. Yeah, I always enjoy looking at M82, the cigar galaxy, in any telescope, because you can see a nice long, skinny haze, even visually, of the galaxy, and just imagining what's going on. If there's probably life of some sort in that galaxy. Maybe looking back at our Milky Way galaxy, wondering, I wonder if anybody lives there. Maybe they're looking at us through something similar to like a telescope. You just never know. All right, I'm going to show them where we're looking in the night sky. So I'm going to grab the screen from you, Jim.
Okay.
So here's where we are. We're looking to the north. We're looking up towards Ursa Major. So again, the Big Dipper. Here's the handle of the Big Dipper, and here's the bucket and the pointer stars that I told you point over to the North Star. The bear itself is right here, and M81, 82, Bodes and the cigar are just off of it, top of his shoulder up here. So they're actually fairly high in the night sky. We've got there's quite a few galaxies up in here that are pretty cool. There's ones like the Whirlpool and a few other ones down in here, but Pinwheel Galaxy. But they're all still kind of low because the tail, the handle of the Big Dipper, at least for us down here. Now maybe if you guys a little further north, it's higher, but for us down here, we can just barely see the handle right now. It hasn't quite rotated around, and everything in the night sky rotates around the North Star. So when you look up at the North Star, our north polar axis of the Earth is pointing pretty close to right at Polaris. So as we rotate around, that's what causes everything in the night sky to rotate. We rotate this way, and the night sky moves this way, and it all rotates around the North Star. So as the night progresses, it might see if I can get it to, I can't really get it to spin too much, but everything later on tonight, the Big Dipper will be up here, and then it'll keep rotating around, and maybe towards sunrise it'll be up here. 6 months from now in the evening, the Big Dipper will be over on this side, pointing towards the North Star. So again, when you see those big camera fields of star trails and whatnot, that's when someone is pointing a camera basically right at the North Star and keeping the shutter open. And as we rotate and the stars rotate around the North Star, that causes those streaks that you see. And if you're into doing landscape or nightscape photography, where you might do some landscape in the foreground and then the night sky up in the background, it's really nice to be able to do some star trails and things like that and get some cool objects to look at. But yeah, that's a very, very busy. Now the North Star isn't all that bright. It's not nearly one of the, it's I think down at, I don't know, number 35 or something like that in brightness. Its prominence is that it is in the same spot all the time. The mariners would have used that as they were trying to using a sextant to get a fix on their latitude. They would have used the North Star to figure out what their latitude was on the Earth. So if you look at the North Star, so like for us here in Tucson, we're at about 32 to 33 degrees latitude. So as you were to look towards the north and use the horizon as your gauge, it's one of the things we tell people is that if you hold your fist out in front of you at arm's length, the up and down part like this is approximately 10 degrees. So for us, if we were to kind of hold it up at the north horizon, you could go, 10, 20, 30, and then someplace right up in there, you'd be able to get your latitude of where you're at. Longitude's a whole different ball game. You know, they again use sextant and other kinds of things to figure out the longitude. That's a lot harder. But if you were actually standing on the North Pole of the Earth, then the North Star would be straight up. It'd be right overhead. And if you were down on the equator, you wouldn't be able to see it because it would be right along the horizon. And if you're on the South Pole, then what they use, which I don't think they have an exact South Polar star, but what they use is similar, would be right straight up. Rick, how you doing?
Better. And I've got one go back.
All right, let me know you ready to go.
Yep.
All right, you got it.
So we now have the monkey head in color.
Looks nice.
You can see the reds. In that picture from Hubble, you could see a little bit of bluish green in the middle. I think we're getting some of that through. Part of the thing is I'm shooting with a color camera with a filter over it that's helping get us the contrast, and that filter itself does some coloration. Sorry, there's dogs barking here. And that's not giving us necessarily the true colors of it. If I took more time with I have a monochrome camera where I can shoot different filters and I can get a closer picture to like what Hubble sees. But in color, this is what we get quick and dirty. So that is the monkey head. Now, over here, we have something else. This is an unusual object to see in the sky. It's the only one that you can see. It's a double star cluster. You can see one right there on the top, and there's another one down below there. They don't have any fun names. They're just NGC 869 and 884. They're located in Perseus. They are quite visible through an eyepiece. You might even be able to see these in a pair of binoculars. They are about 7,000 light years away, and they are close to each other. You have to remember we're looking at three-dimensional space, so sometimes things we see that are next to each other aren't close to each other. They might be separated by distance from us a lot, but these two things are actually quite close to each other. They're only a few hundred light years apart, which in space terms is very close. That's about it. Jim O'Connor, do you have anything to add on these?
Not at the moment. I'm trying to accomplish miracles here too, and it's not wise. I'm
Yeah.
getting some of the utility things I've got on here are sending me, why don't I update it to the next higher status? Even though I told it to leave me alone.
So the double cluster in telescopes that you can have a wide enough field that you can actually see both of the clusters really, I mean, it's just an eyepiece full of stars. If you ever get a chance to look through a telescope or even a pair of binoculars at the double cluster, it is really gorgeous, especially if you have some incredibly dark skies. They almost take on a three-dimensional view. It's we describe a lot of these open clusters as being almost like diamonds on black velvet. They just kind of sparkle like diamonds. We'll show something like this sometimes up in the Grand Canyon, and with the altitude combined with the dark skies, you can really see some incredible things with it. I'll just show you where we're looking in the night sky. So I'm going to grab the screen from you, Rick, unless you got anything else to say about it.
No, go ahead.
So as Rick said, we are looking in Perseus. So this is Perseus right here, kind of standing on its head, we're looking, let me just kind of zoom out a little bit so you can see we're looking, this is now looking towards the northwest. So, not quite due west, but a little bit to the northwest. And the double cluster is right in here in his head. Another easy way to find it, or an easier way, because you can actually see this. If you've got a dark sky, you can see this with just your naked eye. If you come down here to the W of Cassiopeia, you've got a real sharp triangle right here. And then you've got a shallower triangle right here as you're looking at the W. If you use the shallower triangle right here, and then use these two end stars and look way out here in kind of a steep triangle going up here and back down. And you look right up in here, you're going to see a little bit of fuzziness or haziness. And that's the double cluster if you've got dark skies. So again, you've got the steep triangle, and then you've got the shallower triangle from Cassiopeia. And then if you use the two end stars off the shallow one and just go way out here, kind of make your own steep triangle, you look right out in here and you'll be able to see it. And the steep triangle, if you've really got some good dark skies, is a way to find the Andromeda galaxy. So here's the steep triangle of Cassiopeia that you look at. And Cassiopeia, if you look to the northwest is where you're going to see that. But if you come off the steep triangle and go over here towards Andromeda, it's down a little bit, but you'll see a little fuzzy haze down here. So it's not quite straight out from the triangle. You have to kind of arc down a little bit, but that's the Andromeda galaxy. And you can actually see that with your naked eye. It is visible from a dark sky. Just going to zoom out here. It's getting pretty low in the sky right now. Here we're looking west. This is kind of the horizon, and to get the horizon turned back on, but this is looking towards the west. And so Andromeda is about done for the season. It's a better object in the wintertime. It's going to be a little bit higher in the sky. But anyway, that's where we're looking. Jim, you ready?
About I can try to do some magic here.
All right, I'll stop and you can go ahead and start.
What are we doing out there?
Looks good.
Okay, you may have gathered from our conversation that Orion is a kind of a nifty place to in this season to look for nifty objects to see. If you go up and look at Orion's belt in the sword below it, and we've been looking at that glow that's in the sword, that is Orion's sword, the glow that's the nebula. I am about the thickness of the skin on the side of your little finger at arm's length above it. I'm just a little bit above where the Orion's Nebula is. What you're seeing there is an object called, another one of those fancy names, NGC 1911. I'm sorry, 1977. And it's a combination, that's a cluster that you can see over there. But behind it is a blue-green cloud, and that's item 1975. So together, these are an extension of the Great Orion Nebula you were looking at, except you see that satellite go through there? There's a white streak now on there where a satellite went over. The reason I know that it wasn't an airplane was that that image is taking 12 seconds to form, or 15 seconds to form. So it flew across it in what would normally have been about a 15-second time in human time, but in the photographic time, it just struck over. And now it's gone, and that means I'm on the next frame of the picture. Okay, looking in the center. The name of this guy is called the Running Man. And that's that dark cloud in the middle there. And the nebula around it also has dust. from all the star formation that's going around. I don't know if we got into it on Orion, but that Orion Nebula has 2,100 other stars that you can't see behind that trapezium that's lighting up that nebula. And here we've got a similar kind of thing, but what's going on here is reflection. The light you're seeing come back is the reflected light off the bright stars that are there. But there are many thousands of stars in that area as well. But the neat thing about that is the guy who's running, and sometimes, depending on how you trip it, right now it looks maybe like somebody running from left to right with a cape behind him. So I call him running man, and that's Superman's cape he's dragging behind it. Anyway, that's NGC item 1990, 1975 and 1977. The stars are 75 and 77 is the nebula, or the other way around. 75 is the nebula, 77 is the stars. But you can tell the magnitude, the brightness, and the variety in that as we're looking down a line of star formation in space. So the sky isn't just like a spaghetti strainer over your head. It's got depth, and some of them are closer to us and some of them aren't. And Jim, that's the Running Man.
That's a gorgeous picture. You could also almost make out like a little dove with the, the head up front, up top, the
Yep.
body come down with wings out either side.
Well, then there's other versions I've seen that there's a couple of bright stars at the upper part. And if you go right to the upper right of the bright star, that looks to me almost like some people have said it looks like the Twitter symbol.
Hmm. Yeah.
You got to have imagination to look at these things.
I'm struggling with that one, but okay, I'll believe you.
But that's a Running Man, and it's a real nice one. I'm using the maximum performance and gain on this camera, which is saying a lot. And that's why sometimes you're starting to see red or tiny little red and blue on there, because that's the pixels getting heated so much because I'm hitting it as hard as I can to get that image out.
Yeah.
So that's the Running Man.
That looks great. I want to go back with just one object. I think it was when you were showing M82. Carrie had asked, are the two black holes spinning around each other? I think you talked about there was two holes in there.
One on each side of that star or that dust line.
And so, yes, they probably are gravitationally bound to each other, and they were probably black holes that were in two different galaxies as they merged.
Yeah, and the interesting thing about that, about them doing that, is it will eventually, they have to, because they're both curling space in a way that'll make it happen. They eventually will merge with each other, but their velocities are so high that they keep missing each other. Sort of like one way that I heard space scientists explain satellites or even the moon to students, to younger elementary school students, was that a satellite is actually falling to the Earth, but it's moving so fast it misses. And so it's constantly missing the Earth. Well, that's the same thing about those two black holes. They're missing each other for now, but the shrinkage of, say, the altering of how space is around that much gravity is going to make them eventually become the most energetic event in the cosmos, and that's a black hole merger.
Yeah, very good. All right, Rick.
I got more if you ever need them. More items.
Okay, yeah, we could probably do one or two more each yet.
Okay.
Just let me know when you're ready. But while I'm waiting, I'm
ready.
Okay. I'll stop Jim's screen share, and you can start your screen share anytime. And while you're bringing yours up, I just want to let folks know that if you are in the Tucson area, we are doing a Tucson Astronomy Festival. We do this annually, usually in March, and this year it's going to be March 30th down at Brandy Fenton Park. We're going to have solar observing in the afternoon, starting at 3 o'clock, and then we'll have some evening observing. We'll have some telescopes set up, and we're giving away a telescope. We're giving, there'll be some other door prizes in the transition between daytime and nighttime that you'll be able to draw tickets for. And so anyway, that's on March 30th here in Tucson. If you're in the area, we'd love to have you out there. And then actually a little bit later, just the week after the total eclipse, which I'm hoping some of you guys are going to make, we're gonna be heading over to Texas probably for it. But the week after the total eclipse, we're doing an event out at our astronomy complex, which is the complex I told you about near the Chiricahua Mountains, about 100 miles southeast of Tucson. We open up the site twice a year, and we've got several huge telescopes, and we call it Evening Under the Stars, and that's on April 13th. So both of those events are on our Tucson Astronomy website. If you go to the calendar, you'll be able to see it there, and I'll mention it again and show you where the website is. But I just wanted to throw that out there because we do have quite a few folks watching from Tucson or nearby, and feel free to come on down for that. And we're really glad that we've got some great participation from all over the country. We're probably starting to lose our East Coasters a little bit because it's after 10 over there, but we appreciate you guys hanging in with us, and we'll show you a few more objects before we call it a night. So Rick, over to you.
Yes, I'm already sharing. Can you see it?
Yep, we got it.
Yeah, and sorry, it's monochrome again. But what you're looking at here, and it's taking up most of the screen. You can see this lighter gray cloud of gas that looks like a donut. There's a hole in the center, and then all this going around it. Well, this is called the Rosette Nebula. It kind of looks, when you can see it in more detail, it kind of looks like the petals of a rose. Now, there's some remarkable things about this structure. First of all, let's talk about that hole in the center. That hole in the center is being caused by some very hot stars in the middle that are throwing out a lot of solar wind and pushing the gas outward and actually compressing the gas as it pushes it outwards, and that's forming new stars. This is still a new star forming region. What's also remarkable about this object is its size. It's not only large in space, but if you could see this object in our sky, this object is actually 5 times larger than the full moon. If you were able to look up in the sky and see this, that's how big it would be. If I had the full moon in this frame, it would only be about the size of that central hole there in the same camera view. So this is just an enormous object in our sky. Now, you may be wondering why you can't look up and see it. Well, it is a very dim object. Early astronomers identified the star cluster that's here in the middle, and they saw that. It took a very long time before telescopes were powerful enough to be able to pick out this faint nebulosity there. And with longer exposures, this structure is just absolutely magnificent. It's one of the prettiest things up in our sky to look at, I think.
Looks pretty darn good in monochrome too.
Yeah, it doesn't look too bad.
Yeah, I mean, you can see some pretty good detail in there. You can see some nebula,
and then you'll see here every once in a while you'll see a dark line here or there. Those are dust lanes within this structure, and those dust lanes are usually comprised of little particles of dust attached to a piece of frozen carbon dioxide, which makes a very light absorbing material, which blocks out, even though there may be a star behind that blackness, you won't see it because this stuff's blocking it.
very nice. Yeah, that looks great.
Okay.
All right.
You gonna show them where that is in the sky?
Yeah, let's see. That is, do you remember what the number is?
Oh, you would ask me that.
Let's see, that's the
Hold on. We can cheat. There you go. 2238.
2238. Okay. Oh, cute. Okay. Yeah, let me share the screen here and I'll show you where it's at. It's Okay, here it comes up. It's right in the nose of Monoceros. Monoceros. I never pronounced that right. But yeah, it's right up here, Rosette Nebula. Well, that's just to the left or north of Orion. Okay, very cool. Jim, how you doing?
I'm ready.
Okay, you got it.
Okay. Go try to. There's your screen. Share. Okay, the object I'm going to be showing here is in the constellation Cassiopeia, and it's right near the a, a star right now. Where the way Cassiopeia is in the sky, it's she's coming down. She's upside down right now, and that's a punishment for her being so vain. And so Zeus put her in there. She's chained to a chair in there. She was an evil queen, but she's upside down right now. And what would be her knees are actually the points of stars that are up at the top of it. And this is New General Catalog item number 450. And it's called the Owl. And I like to use this one once in a while because it kind of looks like what it is. I'm actually going to brighten up a few of the stars right now and see if that helps. A little better view. This is an open cluster that's relatively young. And let me get a little bit more. Whoa, they're going to go away for a second, but I'm going to make them come back. There they come. Okay, this is the owl. The two bright eyes on the upper left part there um, kind of set it off. You'll see a line of stars that are horizontal going out towards the left edge, and then right in the center of the owl, a line of stars going up to the right, up at about a 45-degree angle. Those are his wings. And his feet are down there at the bottom. Some pretty tiny little feet there tonight. Um, that um, that particular object, I cheat a little bit here. I'm going to say that that again was found like almost every item I've been showing tonight by William Herschel in the 1780s. It's about 8,000 light years away from us. The estimated age of all those stars is 21 million years. They were all formed about the same time out of the same cluster. Um, there's an estimate of about 150 stars in that object. So there's 150 stars, all about 21 million years, but this is a classical cluster, which means it follows the rule we try to have for four clusters. And what the rule is that in a gas cloud, you can't tell the gas cloud is actually rotating because it's so big and non-distinct. But once you make stars out of that stuff, if stars move with respect to each other, you can really notice it right away. And so what we have noticed on these things is the Milky Way rotates. Everything in the Milky Way is rotating. And when that cluster of stars get formed, sometimes the stars aren't tight enough together, they can keep that identity going. So this one, in about another probably 30 or 40 million years, is going to be unable to be seen in the way we see it right now. And another interesting thing about those two stars, the eyes that really set it apart from just a bunch of stars, the hint is they're not part of this cluster. They are actually only about 4,000 light years away from us, and they just happen to fit in the picture. So astronomers, when they're talking about the romance or mystery of the sky, they'll include that in this object. But if you try to get scientific on them, they're not anywhere near the rest of those other stars that make up the owl.
Yeah, I always enjoy showing this one at star parties because even visually in a visual telescope, you can very clearly see the eyes, and the body and the wings coming out. Sometimes he's flying on his side, sometimes he's upside down. That's also sometimes called the ET cluster because of the bright eyes. They
Yep.
almost look like kind of bug eye extraterrestrial, the typical extraterrestrial view you'd see. And a
Yeah,
lot
it
of
looks like ET
yeah,
trying to say no disassemble.
that's right, exactly. So sometimes I'll put this up and say, okay, here's your test for the night. Tell me what you see. And I've gotten all kinds of things, but you know, hey, whatever your imagination comes up with works. But yeah, we call this one the owl cluster or the ET cluster typically.
And the other name I've heard for it is a Kachina doll. And I Jim's heard me tell this story too many times, but when I was doing a star party at Davis Monthan Air Force Base for some Boy Scouts, it was a Boy Scout camporee, and I told it those three things, and about four of them all said that looked like an F-15 with its afterburners going, flying away.
Uh, yeah, that's a good one. All right, I'm going to show you where we're looking in the night sky for this one.
And I'm ready for the next one too, Jim.
Okay, so here's where we're looking. So again, we are in Cassiopeia, right off of her knees, like Jim said. It shows here dragonfly cluster. I guess that's another name for it as well. But that's the cluster. So again, you've got the steep part of the triangle and the shallow part of the triangle off of here that we were using to find the double cluster earlier. Now, if you come off of this point here and you just move down just a little bit below it, you'll come to the owl cluster. All right.
Interesting thing about Stellarium's choice of an illustration for it is that Cassiopeia is looking in a mirror. And that's what got her into trouble. She was so very vain. She was jealous of her daughter, right to the left of her, Andromeda, over there. And she was not very kind to her. She thought that Cassiopeia thought that she herself was the most beautiful creature in the universe, even though her daughter was prettier. And and the interesting thing is they don't have an ethnicity about them, but the other name for Cassiopeia is the Black Queen because she was the queen of Ethiopia. And her husband Cephas is the next cluster over, right next to it, was her husband, the king. And they were mortals. And there's a long story about why she's chained to the chair. But Zeus finally got mad because he couldn't destroy her because she did a favor for Poseidon. Poseidon made her immortal, her and her husband. So they couldn't kill him. So they have them upside down half of every day.
All right. So we'll turn it over to Rick and Jim if you want to do one more, and then we'll start wrapping things up. And Rick, you can do one, maybe two more.
Yep. Okay, so this is two objects in one. You should be able to see some red nebulosity kind of come from a point down here and spreading out in towards the back. It's a pretty large nebulous object here. There's a star cluster in all of this, and the star cluster is called the Christmas tree cluster. You kind of got the point on the Christmas tree up here, and it's spreading out that way down there, all the lights on the Christmas tree. Now, the object in this is the Cone Nebula. And you would think all of this is the Cone Nebula, but it's not. The Cone Nebula, right down here, you'll see a dark cone-shaped object. That is what is called the Cone Nebula because of that cone shape that's formed down there. So really, this down here is the Cone Nebula. All this is the Christmas tree cluster. And this is about it's about the same as the other nebulas I've been showing you. It's about 2,000 light years away.
Yeah, it's got some beautiful red to it. And
Yeah.
you can see
Yeah,
the cone. I don't know if you pointed it out or not, but you can see the cone right down to the lower right of the nebula.
Yeah. Yeah, right down there. And this is also an active star forming region. All that hydrogen is condensing down and making new stars.
Yeah, and you can see some nice dark, and heavier dust lanes in there. A couple of that really bright stars, probably a foreground star, I would guess, to the nebula, but it might be part of the nebula. It's kind of hard to tell because it is in a and more of an open area. All right, well, let me show you where that is in the night sky. And Rick, are you going to be able to do one more?
Yeah, I think I'll have one more in about 3 minutes.
All right, so I'll show you guys. So we're back in rhinoceros, I think. Let's see. Yeah. So earlier we were looking up here in his nose with the Rosette Nebula. Now we're up here where his horn is, and the blinking part right here is the Cone Nebula, and then the Christmas tree cluster is just right above it. So that's where we're looking, just to the left of Orion. There's a lot of really cool things coming up in the night sky in this area. We didn't do anything in it. I don't know if it's up yet or not. I was looking for Leo, but I don't think it's. Let's see. Oh, there's Leo. A lot of times, Jim, just let me know when you're ready.
Okay, it'll be a few seconds.
A lot of times, Leo is actually fairly prominent. If you look right now in the east, you'll see kind of a bright star. It's called Regulus. It's right down here. But if you've got, and you don't have to have really dark skies, but decent skies, you'll see what looks like a backwards question mark right here. And that's kind of the main of Leo, the lion, Leo. And so Regulus, it anchors it down here. And then his body actually comes down this direction. So when you talk about the Leonids, the meteor shower, they're emanating out of Leo. So typically that's what we're talking about there. So that's off in the east, and it's pretty prominent. There's lots of really nice. There's galaxies in there and all kinds of cool things to look at. It's a fun constellation to peek at. Just above it is Cancer the crab. I don't, looking at the line figures and what they've what you can actually see in the night sky. I'm not sure how they get a crab out of that, but I guess you can, with an active imagination, you can. Sometimes you can.
I can do it anytime you want to, if you run out of things to ramble about.
All right, I will stop the share and turn it over to you for your last one.
Okie dokie. Ooh. Let's see. I keep forgetting to hit share the second time. Okay. What I have is another item in Cassiopeia, and it looks like, and what I'll do is I'll talk while I'm making a bit of a change. Um, the the night tonight is better than when I first worked with some of these, and they're coming up brighter and a little more confusing than I'm used to. So I've just changed the time that it's imaging this. And if you're looking at the bottom of your screen, you can see a thing that says exposure around that thing, and it should be. See, I changed it from 8 seconds to 6 seconds, so this is going to start getting darker because I'm also stacking these things. So as I keep stacking less light, it's going to look a little darker, and that it'll also help get some of the extraneous stars out of there. Okay, this is the ghost goblet. And a goblet is sort of like a big chalice like drinking glass. And why it got named the ghost goblet, I don't know. I just use it on Halloween a lot. And I don't know if my cursor is that going there, Jim? Or is my cursor separate?
No, we can see your cursor.
Okay. Well, I've got my cursor on it right now, the fist that's there. But there's a couple of loops of stars right in the middle that look like um, the side view of a cupped hand. There's a few of them there. That's considered to be the bowl of a goblet. Now, I don't know how they got this kind of creativity with this object way back when it was discovered, because right now I'm smacking that thing with 60 times the gain that normally your eye would get. And I'm also doing it for 8 seconds and your a time for 3 times or 6 seconds. And your eye only takes 6 seconds of 6 pictures a second. So I'm pumping a whole lot more energy out of there than your eye would ever see. Yet they saw that in a single eyepiece on a telescope way back 300 years ago. So they got a lot of imagination. That's a ghost goblet. Let me give you some facts about it. Um, there. Um, that thing is in Cassiopeia again. Cassiopeia is really full of a lot of these clusters, and there's a reason for it. If in the summertime or later in the spring, really, if you're out looking up at the sky and you see Cassiopeia near in the northern sky, especially say in late June, mid to late June, Cassiopeia will be coming up on the right side of the North Star. And all the way south to the southern sky, you'll see the constellation Sagittarius and Scorpius. And that band from Cassiopeia to Sagittarius and Scorpius, if you look up in the sky, that's the summer Milky Way. So any place you look in that Milky Way, you're looking into the center or into the insides of our galaxy. So you get lots more of these, what we call eye candy kind of things to see. When you look for galaxies, you're looking perpendicular to that line because you don't want to be staring through all the stars. You want to go into deep space. So right now, this one is one of many 25 or 30 really interesting open clusters that are in Cassiopeia. As far as this one is concerned, the Ghost Goblet, it's about 3,700 light years away from us. It's 7 light years across, just that little center part. So you're seeing a lot of the stars from the Milky Way get in there. And the interesting thing, because they're so dense and those stars are so tight together, and there's so many of them, it's 2 billion years old. There's 50 stars in that asterism, or the group of stars we're calling the Ghost Goblet. So the rest of the things, most of the things you're seeing on the sky are in the Milky Way, in the area of the constellation of Cassiopeia, but they're not part of this cluster. This cluster only has, by itself, held together by its own gravity, 50 stars. That's the Ghost Goblet.
Yeah, it's always kind of interesting to look at some of the asterisms and try to figure out you know, what their background was, what their history was, how they came up with them. You know, a lot of times, you know, I'll just go in the backyard with my wife, and we'll just kind of look up there and kind of make up our own constellations and objects, and just let your imagination go wild. All right. Well, thanks, Jim. Rick, you ready for one more?
Yes, sort of. I got an image. My telescope drifted out of focus a little bit, but I think you can still get the point of the object here. Let me get here where I can share. It's not completely out of focus, just the stars are not as sharp.
Okay.
So this slightly blurry thing is called the Seagull Nebula. And I think you can kind of see that. His head is up here. Here's his mouth. And he's got his wings spanning out on either side. This again is a very large object in our sky. I mean, all the pictures you're seeing are taken with the same camera, and I'm not cropping anything. So this object is filling the frame here. It's even larger than the Rosette Nebula was. It's about 5,000 light years away, and it's a little over 200 light years across. So it's further away, but bigger than some of the other things. So it's if this was as close as the Orion Nebula, it would be extremely large in our sky.
Yeah, that's a gorgeous picture. I think you got froze a little bit there on the stream, Rick, but I think you're back now. I noticed you
Yeah.
put. Very cool. Yeah, that's a gorgeous one. Another one that you pretty much have to have a camera to be able to see the detail too. All right.
No.
You that one?
Nope. Nope.
Oh, okay. All right, I'm going to just share out our next event so that you guys can see that, and we'll wrap things up. I'll just give everybody a chance to say a few final words. I'll just throw this up here so that if you are in our area, so we do have our next virtual star party, as I mentioned, will be we're planning right now October 25th. So in the fall, we'll probably stream it to Facebook, and then, like I said, we'll put stuff on YouTube afterwards a couple of days later. So feel free to check those out or share that around. That's good. Again, if you're in Tucson, we've got the Tucson Astronomy Festival, March 30th at Brandy Fenton Park, and then our semi-annual Evening Under the Stars at our Chiricahua Astronomy Complex out near the Chiricahua Mountains on April 13th. So fingers crossed that we have good weather for that. Here's our website. There's our Facebook page, which you already know since you're here, and our YouTube channel right there. So again, thanks everybody for hanging out with us. We enjoy doing this kind of stuff. We started doing this when COVID hit, just like everybody else. When we transitioned to not doing in-person stuff, we thought, well, let's try to do some virtual stuff. We just do it through Zoom because it's easiest. We're familiar with Zoom. We know how things work there, but there's a lot of different ways to share it out. But we have quite a few of them on our YouTube channel, so definitely check that out. And if you want to join us, we do a bunch of events here in Tucson. So again, go to the website. There'll be a calendar there. It's usually updated maybe 2 to 3 months in advance. Sometimes you won't see them as far out, but you can look around. We have the dates for the Grand Canyon Star Party listed on there as well that go out to 2035. So that's a good one. If you're ever thinking about doing the Grand Canyon, especially in the June timeframe, try to time it when you can come up for the Star Party. I think you would just absolutely have a blast. All right, Jim, any final thoughts?
Yeah, it was a lot of fun tonight, working almost in a scramble mode because of missing Bernie. And I was just happy everything worked. And it's really fun to give these things out to the public. It's really fun to explore the sky and to let people know what we get to see a lot of. It's lets you know there's something bigger than yourself that's out there. And I just really love to do these, and I'm glad people have stuck with us and hung in there.
All right, very cool. Rick.
Yeah, again, thanks everyone for their patience. Again, these things are never easy, and the weather the last few days also didn't help us. We weren't able to get out and check out our equipment in advance like we usually do with all the rain. So we were kind of running everything dry running it as we were doing things for you here. But I do encourage everyone to attend some of the upcoming events that Jim mentioned. And also, if you have a pair of binoculars, go out right now and go look up at Orion and see if you can spot that Orion Nebula. I think you'll be quite pleased with what you'll see.
Yeah, all right. Thanks, Rick. Appreciate that. And so with that, I think we'll call it a night, and hopefully we'll see you guys at some of our future events, and certainly maybe at the next virtual one we do. So you guys all have a great night. If you get a chance, absolutely, you want to try to see the total solar eclipse April 8th if you can get into the path of totality. But if you can't, and you can just get in and look at the partial eclipse, You know, if you've got an astronomy a club nearby or something, they'll probably be setting up a few things. Here in Tucson, I think Flandreau Science Center is planning on doing an event down on the University of Arizona Mall that's going to have some telescopes set up to look at the partial eclipse. It's right around late morning, early afternoon kind of timing. But it is good if you can ever get to totality, which is just kind of a narrow window. It's just really, really neat to be able to see the total eclipse in there. All right, so with that in mind, I think we will call it a night. So everybody have a good night, and we'll see you at the next one.